Hey, welcome. Good morning. Hope you're having a good morning so far. This is Mr. Natsky. Sorry, I am not there today. I'm out of town. We're at a conference here, so I'm unable to be there. So hopefully at this point, today you looked at symmetry. You should have at this point already been in the activity. So that's what we're going to talk about is two types of symmetry. You should have completed the 3.4 formative and checked your answers. If you did not, here is a slide of the answers. You can check them quick. If you need to, pause the video. And then we can go on from there. What you looked at is a symmetry activity. You all should have been given a shape, a half sheet with a shape on. And you were supposed to identify what type of transformations occur. What we're looking for is what rigid transformations can create an image that fits exactly over the other. What we're looking for in symmetry is creating something that if you do it to it, you can't tell it actually happened. And in this case, in this star, we can reflect it, okay, do a reflection, or we could do a rotation. And it would end up as the exact same image. You were given a shape, you're going to try to explore. Can you rotate it and get it back to still be the same image? Can you put a line and reflect it? And draw a line of reflection down the middle that will allow it to be the exact same image. Okay? You had a shape, looked at it. If you look at the ones and what we explored here in class. What's true for all the lines of symmetry in these shapes? They're a reflection. Both sides of the line are exact replicas or images, are the same image. Okay? What's true for all angles of rotation? That every time you rotate it, you get the same image. Okay? Is it possible for a figure to have rotational symmetry and no reflectional symmetry? Yes, it is. We will talk about and look at this some more. On the back side of your notes, here are some of the shapes we had. We've got the square, equilateral, triangle, regular hexagon, regular octagon. We've got a rectangle, regular pentagon, circle, parallelogram, an isosceles, trapezoid, and a rhombus. None of you had the parallelogram or the circle. We're going to come back and talk to those a little bit later. But first, I want to talk about what is symmetry. Okay, symmetry is when a figure has symmetry if a rigid motion exists that will map the figure onto itself. We have two types of symmetry that we are going to look at here today. The first is what we call reflectional symmetry. A figure will have reflectional or line symmetry if a reflection maps the figure onto itself. Each of these lines of reflection is called a line of symmetry. You'll notice I've got a McDonald's M here. If I draw that line right down the middle, the left side of the line and the right side of the line are exact images of each other. I've got here a Jamaican flag. If I draw a line from left to right and a line straight up and down, those images are exact replicas of each other. If I flipped it, you wouldn't know. Okay, if I flipped it or reflected over that line, you would not know the difference. That is reflectional symmetry. So I'm looking for a line that cuts it in half. Same image on the right, same image. It's a mirror of each other on both sides. That's reflectional symmetry. Rotational symmetry, a figure of rotational symmetry, if a rotation maps the figure onto itself. The angle of rotational symmetry is the smallest angle of rotation, less than 360, that will map a figure onto itself. Now, if the only option is to turn something completely once and be 360, we say it has no rotational symmetry. Okay, you have to be able to at least turn it to some angle less than 360 to get there. So like in the Jamaican flag here, has rotational symmetry. If I take this and turn it, and as I turn this here, you will notice it's now the same. That's a little off center, but it's the same. You can't tell that I changed it. I just turned it 180 degrees. I can turn it again another 180, and I get back to the same image. Okay, so there's my 180 rotation side by side. Can you tell the difference between the two? No, you cannot. Okay, and then on the right here, I've got a hexagon. And I'm just looking at the hexagon, ignore the writing and the arrow to the left. Okay, we're going to say this hexagon has rotational symmetry of 60 degrees. Now, how do we get that? That's the question. Okay, I can turn this. Now it's the same. That's one turn. I can do another turn. Oh, it's the same again. A third turn to get back to the same. A fourth turn, a fifth turn, and now I'm back to a sixth turn. So I can turn it 6 times, turn and stop it 6 times before I get back to the exact same way that I started. Okay, well, so what we say is it's got, and we call it n-fold or 6-fold rotational symmetry. Now, one complete turn is 360 degrees. So how can I find the angle of rotation? Okay. I can take 360 and divide it by the number of times that you can turn it in one complete rotation. So for example, on my hexagon, I turned it 6 times. So if I take 360 and I divide it by 6, that gives me 60 degrees. That is my smallest or angle of rotation. Now back before I showed you kind of we talked about what are all the angles of rotation. Well, I just take the multiples of 60. I'm going to start with 60 and just add 60 to it. So if I'm looking for all angles, 60, 120, 180, 240, 300, and 360. I like to include 360 because that tells me that I'm done. Once I get to 360, I go. And the other thing too is if I don't get back to 360, that also means that I do not have a full, I can't rotate it evenly. Okay? So you have to be able to get to 360 in order to rotate it. That is rotational symmetry. So this is on your notes on page 3. Now we're going to look at some examples here in the middle. We're going to identify the types of symmetry for each figure. Number 1, the star-like look and shape here. It has reflectional symmetry. Okay? Can I draw my lines of reflection? Yes, I can. Straight up and down, cuts it. There's 1. Left to right, that cuts it. There's 2. I can also cut it diagonally 2 more times. So I have 4, okay? I have 4 lines of reflection that gives it reflectional symmetry. It also has rotational symmetry. What I do is I start with, okay, pick a point. I'm going to start here. Okay? And I can turn this. 1, 2, 3, 4 times. So I can take my point, my star on the right, turn it. There's 1, 2, 3, and I get back to where I started, that's 4 times I turned it. So to find my angle, I'm going to take 316 divided by 4, 90 degrees is my smallest angle of rotation. If I want to list them all, I'm going to go with the multiples. So all got 90 degrees, 180, 270, and 360. The oval that you see over on the right has reflectional symmetry. I can divide it left to right and up and down. I've got 2 lines. It also has rotational symmetry. If I pick a point, if I pick this point at the top, I can turn it. So if I start here, there's my turn. There once and twice to get back to where I started. So if I show that, turning it, there's once, twice to where I started. So to find my smallest angle, take 360 and divide by 2. My smallest angle is 180 degrees. If I want to list them all, it'd be 180, and I'd also list 360 because that gets me back to where I started. Our last example in the air. So the figure to the right, Adam was asked to draw all lines of reflection. His work is shown. What did he make? Well, this line right here. The horizontal line that you see is not a line of reflection. So therefore, he put in one too many. The line that goes up and down, the vertical line that I'm highlighting here in blue, yes, that is, because the image on the left and the right are the exact same replicas of each other. So that's kind of our notes and our summary here. Go ahead and complete the check your understanding. You're using the words from the word bank you see here with related to these figures. You can use some words more than once. Some words do not get used at all. Go ahead, complete that. Once you've completed it, you can check your answers in Schoology. If you go to the calendar, there's a link and the completed notes are filled out there. And it also does, if you want to look back to the other ones, you can see them as well, and you can fill that. Before you do start, I do want to go back to, and I do want to talk about the circle. The circle is the one shape that I can draw an infinite number of lines that will create lines of reflection. There is no maximum to it. There's also an infinite number of angles. I can turn this 1 degree. I can turn it a half a degree, a quarter of a degree, a tenth of a degree. There's an infinite number of turns you can make in order to make it because it's the exact same shape all the way around. And a parallelogram is one here where you see it has no lines of reflection, but it does have rotational symmetry. Whereas like in an isosceles trapezoid, I can create one line of reflection down the middle, but I can't rotate it. There's one that does not have any rotational symmetry at all. So those are 2 examples of where it's got one or the other. It is possible to have it. So go ahead, complete your check your understanding. You can check your answers in Schoology on the calendar. There's a link there. They're posted there. Once you have completed that and checked it, you stop in and talk with the substitute here, and they can get you a copy of your independent practice, and you can work on that. Just a reminder then, next class we'll do a quiz review, and we do have a quiz coming up on Monday and Tuesday, November 3rd and 4th, which for you will be next week. So get that on your radar. We got a quiz coming up in 2 class periods from today. Thank you. I hope you enjoy the rest of the day, and I look forward to seeing you back here shortly in a couple days.